Yeah, it has been a while and this has been my biggest personal failure ever since I do anything 3D printed. We can see loose bolts right over here. It popped off the bracket and we had a major blob of death on our newly introduced Goliath. It did one print and it got absolutely smothered under PLA junk. So it took a few days just to try and figure out what to do next with this printer. I started looking online. I was fully prepared on buying something CNC pre-made from AliExpress until I found a design, some kind of unibody. It was made by Cristian. I met Cristian on the Discord. I had a little chat about it and that made my wormhole even bigger and I started designing myself. So I took his design, I took it as an inspiration and together with today's sponsor PCBWAY, I'm going to try out a few things. It is going to involve milling some 7075 aluminum. We also have some 3D printed aluminum and I hope this is going to be the point. I turn my lovely red and I evolve it in the beast that I want it to be. For instance, this is completely printed out of aluminum. The only thing I did was make some threads right in here with my tab. Also right over there we needed them and we needed two right over there. That's why we can see the grease marks. This is from me oiling my tab. So yeah, this has been printed out of aluminum. It is absolutely looking like $1,000,000 and we are going to weigh it later in the video. This right over here is what they call a tab. Nothing special. The only thing special about this tab is going to be that the main threading is already starting millimeters after the point. Normally when you thread, the threads are going to finalize the more you turn it in. Well, the threads are already fully well made right over here. So this is going to be a tab for blind holes. So for holes that are not completely drilled through, this is going to be the tab that you need. Also made this tapping block, printed on the GD+4 and we can see the first multicolor print that actually worked out nice. The deal is going to be you slide it over, you want this surface to be flat on your object and then you can gently turn it in, making all your threads straight. Because the last thing we want to do is take these expensive pieces and make a crooked thread that the bolt is not fitting in. So time to do my final threads and I think I'm going to try and polish this because we are dealing with some very attractive aluminum that is bare and it is shiny and this one is a little bit of a stain in my eyes. So I'm going to try and see if I can polish this. So this is going to be part of our belt clamping. We need two threads right over there to turn in a bolt. This is going to sit on top, squeezing the belt and you can see a little slot in the side. And this should be capable of holding in our belt very securely. It looks like everything is working. Great news! We are going to do a little bit of a montage because I don't want to make this a 1 hour video. Cue the music and let's go! We did a little bit of sanding. We used 200, 400, 600, 800 and we even did 3000 grit. And after that we did a little bit of polishing with the polishing wheel and I'm going for the dual tone. So we have the chrome side flanks also right here on the side. So I call it the speed shapes and then right here in the middle we still acknowledge that this has been completely printed out of aluminum. So we are going to keep this bare. Then I also finished up this part, 2 threaded holes here and 2 threaded holes right over there. We can also see on the back side we have a little bit of a slot going on and that is going to be for the following purpose. So the purpose of these callouts is that when I put this part in like this, it has no place to move. The same thing is going to be true for this part. Once it slots in, it has no way to move. Now, unfortunately, with the 3D printing process, we now have on the aluminum 3D printing, we lost a little bit of detail. Which also means when I put this part in right over here, we don't have quite the perfect alignment between the top and the bottom part. Now, is this going to be problematic? I guess we will figure out. I did try to clean out the inside, but it wasn't very easy. Then we also have the Funzer XY joints. These should replace all the plastic parts in the printer. Now, unfortunately, these bearings are very, very poor quality. We also purchased this carbon fiber beam to replace the X gantry on the RatRig, and the same thing can be said about this beam. The quality is also not that great, also made by Funzer. So if you are still wondering if Funzer is making great quality, I can tell you right now it isn't. And this is going to be the issue. You can see this beam is not square. The first thing I will be doing is removing the cooling fluid because we have some work to do. Some things I already done off screen is replace this LCD screen. This LCD screen was broken because of me. Wired it wrong, I fried it, it was that. But right now it is working perfectly fine. And why is that important? Because when the pump is not running or when the temperatures are getting too high, this pump is going to warn me with an audio signal. If the screen is dead, it doesn't work. So right now that part works. And not only that, I also have this piece of acrylic cut out with the Corvera Air because there is a very nice and very cool water block inside. We don't see it right now, so we're going to change some things up. We are going to put in a screen so we can finally see back our very beautiful and fully copper water block on our BTT Octopus. So we have a bunch of work to do on the back, and on the other side we need to change out the X gantry, the XY joints. We need to rebuild the complete tool head. So I have quite a lot of work to do and I need to stop yapping about it. So let's go.
Man, this might be something lethal. Like a beast that can't be tamed. This the kind of rage you can't contain. Yeah, this might be something lethal. You can really see the flames. Feeling like it's borderline insane. Man, this might be something lethal. Something lethal. Yeah, this might be something lethal. Feel it coming. The pressure start thumping, ain't no running. It might cause a rave, all my people start jumping. You can feel the blood, shit, it get your blood pumping. Okay, you better take a seat. Don't step inside the kitchen if you cannot take the heat. It's looking like a feast, guaranteed to flame the streets. It's a jungle outside, tell me who can tame the beast. Something lethal, like a beast that can't be tamed. This the kind of rage you can't contain. Yeah, this might be something lethal. You can really feel the flames, feeling like it's borderline insane. Man, this might be something lethal. Something lethal. Yeah, this might be something lethal. Something lethal. Welcome to the valley, it'll eat you alive. It'll hit you out of nowhere like a thief in the night. Ain't no way you can hide it.
Alright, before we assemble everything, I want to do a comparison between the new stuff and the old stuff. So this is going to be the stock configuration. We are going to put everything on the bed, the tool plate, and then we have our beam like that. And now it's calibrating. We have 0. Now we are going to remove everything. We have a total weight of 606 grams. So we are going to add the new parts like that. We also need those, our tool plate, and then our beam. And we are saving around 245 grams, which is actually pretty amazing. We are going to gain so much acceleration in the y-axis. 200 grams is not to joke about. This is actually quite a lot of weight we are reducing on the accelerations. So what are going to be our biggest savers? So we are going to start with these parts right over here. The CNC mounts are going to save us 160 grams. The original tool plate and the new tool plate, so this has been revised. It's also a little bit thicker in the middle. We also made some weight saving features. Places that don't need that support. Also right over here, these cutouts for the bracing. This is going to come in at 0. So that means that both of these are weighing equally, while this is 7075 aluminum, much stronger, much stiffer material than this. So this is already going to be very valuable in our tool head stiffness. This is going to be our Hotend mounting solution, and we have our fan duct. Let's see what this is coming in at. That weighs around 31 grams and we gained around 30 grams. So this is actually a lot heavier than these parts right over here. So while we are saving some weight left and right, we definitely are gaining some weight on the hot end. This is around 30 grams and then the Goliath is also around 20 to 50 grams. So we are definitely going to add more than 50 grams of tool head weight while we are saving a bunch on the y-axis. Very interesting to see how this will influence our acceleration tests. Now, enough rambling. One thing I need to do before we can start the assembly process is remove these bearings because these are horrible. Alright, fitted up the carbon rail with the Funzer mounts and I am quite disappointed right now because it doesn't fit. We are about, I would say, 3 to 4 millimeters out of room. Basically they are too short. And for that we need to remove everything and replace it with the old tubing. It's that or I need to start filing the holes bigger and try to do it that way. Great news, I think I did it. I got the Y running fairly smooth over the complete axis. It was binding up pretty hard, so I loosened all the bearing rails on both sides and I tightened them in order of moving the gantry and hoping it would align. It seems that the beam is not super twisted. That's very good. The only thing right now I don't know is going to be the x-axis and how straight it is going to be in correlation with the rest of the frame. So I guess we'll see where we are going to print. That also means we can finally begin on the tool head. So let's go! I need to do some explaining because we made kind of a big oopsie. And to PCBWAY, I'm so sorry I had to cut away some aluminum you guys milled because my design apparently has a massive design flaw in it. So it now slots next to the bearing. So the bearing is also pushing in this belt. And we now have a belt that is hopefully good enough to not pop out. Not sure how I screwed that up. I must have looked at this tool design for more than 10 hours and still I didn't see it that we were screwing up our belt mounting system. Oh well, it works right now. This is not going to be a production model, but it works and that is right now, honestly, all I care about. And here we have it. This is going to be what I had in my mind for the Goliath Hotend. Is it practical? Hell no. You are better off getting the one from Cristian and then redesigning all the rest. This is just because I can. Nothing more than that. But I freaking love it. Time to finish everything off. We need to mount the end stops. We need to rewire a bunch of this stuff and then we can put in our first heat. And here we have it. This is going to be our first speed test. We have some weirdness going on when it didn't slow down. So the parts right over here, we can see some ugliness. All the rest seems to be fairly fine. Let's take a closer look. So judging from this corner, we were doing perfectly fine. It is only going to be with these long straight faces. We are starting to having extrusion issues, or at least that is what I am thinking, because this part right over here is looking perfectly fine. I also milled out a bit of acrylic, so we have a view window. We are going to do some magic, move some stuff around, and then I think we can put it back in its cage. Fingers crossed. We're going to do a bunch of printing, and we will see if we are going to have a dumpster fire or not. Good morning. We had a bit of a problem. I woke up, came to the shop. Everything was filled with coolant on the floor and the table. Yeah, not only that, the Raspberry Pi in here got completely showered with liquid coolant. And the reason is because this boy decided to leak. And it leaked like crazy. So I left the printer idle. The system was running normally. I woke up, everything was covered, and all the coolant was gone. Luckily, the pump didn't die. There was just barely enough coolant in it to keep it alive. But everything dripped out over the boards. I had to disassemble everything sooner than I wanted. I wanted to do some more printing because we want to do some cool stuff with the back housing like I told you. So this right over here needs to change. This is going to move, this is going to move, and we are going to add a new window so we can see our block. And now I'm pretty happy. I can also see if it's going to leak. Now it was dripping out of this part right over here. So it was very obvious because the whole floor was full of it. This is going to be the time that you send your prayers to me because I'm going to need all of them. All right, let's go. Now this is super interesting. We can see it fog up, and for good reason, because when I do a temperature check on the side, we are at 44 degrees on the copper block. So this is a solid copper block cooling all these steppers. And yeah, you can see it even with a chunk of copper. We get not high temperatures, but still we get some heat into the block. So I'm actually pretty happy it is water cooled, even though we had a massive leak. All right, we found the culprit of why everything is continued to leak. We have done everything again and we saw it leak again. And you can see it right over here, the gunk on the water block. So the O-ring was completely deformed and stuck to the acrylic top. I got a super sharp knife. I'm going to scratch everything off, reapply the same O-ring, and then order some decent ones because this is not acceptable. I was able to make it stop leaking. For that, we had to do some sanding. So I did a bunch of wet sanding because the middle of the acrylic block was actually worn in. So the black that we could see was worn into the plastic, probably because it got loose enough and the something started rubbing, wearing down the parts. It also warped a little bit, probably because it got too hot because we ran out of coolant. So self-inflicted wound again, and if we are going to have that problem again, I will probably switch it out from a clear acrylic to some other engineering plastic. We are going to do some calibrations on the PCTG from 3D Jake. So 3D Jake, if you're watching, thank you very much for providing me with the spools to do all this testing to make our new back housing. There's also a code down below. You are getting 10% off on all your orders that are not on sale. I don't earn money on it. It is all for you guys. 10%. It's quite a lot on the web shop. So go grab your code, use it on all the things. And yeah, fingers crossed that this is going to be the last thing that we are screwing around with, because in order to make it in those 3 weeks, that ABS sprint, woo, this boy is going to be busy. So fingers crossed. Let's go. All right, finally at the point I can show off some of the things we have printed with the Goliath. Good news is, or actually great news is, the Goliath is flowing like an absolute hooligan. Right here with this 3D jig PCTG, it is absolutely flowing like a madman. And we came up with a design that is actually fairly smart and I'm really proud of. So this part is going to be for the back housing. We have our adapter ring. This is needed for us to make room for the radiator, which is going to be sitting inside. And right now, if I want to replace it, I have to loosen 4 bolts in each corner to do all the disassembling so I can get on the inside of the printer. And right now, like you can see, we have some tabs right over here. So this is going to be mounted on the back side. And this front cover where everything is going to hang on will just slide in like that to one solid piece. So if I ever have to work on it, I just need to yank it and the outer panel is coming off. So we are going to do the replacement of this back housing. I'm going to replace the gantry. I'm going to do my final calibrations, and then I want to do one massive print just to show off the PCTG and what this printer is capable of before I start my commission work. And here we have it, the end of the RatRig story for today. And to give you an example on how good the system is running right now, we are pushing 50 millimeters cubed on that thing like it is nothing. All of these parts right over here, so these are customer parts. These are about 15 of them. These are all printed under 10 hours. That is how crazy the flow has been. And to finish off the project, we did another PCTG test from 3D Jake. This is just completely random, but this is going to show you what a really engineering part would look like. This is for some sort of an intake of a car. I don't have that car, but I thought it was a cool model to show off. This took around 9 hours because of all the support inside. So the switching to the support, that is fairly slow, and also deliberately set it slow because I want the quality and I don't want it to have that massive amount of speed. So the supports are reliable. So let's have a look inside and see what we came up with. Also, another thing I can say is that all the mods we have done inside the RatRig have been absolutely reliable after we have done a lot of digging around. This machine really has put me through what I call the Murphy Law. It has been absolutely terrible the past few weeks. I think this build has taken twice as long as I was anticipating. We had so much stuff going wrong. We had our belt ripping on the left side, reason being that the clamping thingies I designed were too sharp, cutting into the belt and then just ripping them. And we actually have a model to show off what that looks like when we were cutting the belt. The belt was starting to stretch. This is what that belt was starting to look like. It also started stretching like that. And this is going to be the perfect example of a belt that started stretching. So you would think these are skipped steps. Nope, this is just purely from the belt stretching. Then we also unfortunately got a bunch of leaks, not only on the tool head after removing the silicone tubing, but we also had a massive leak right in the back on the electronics compartment, the ones that are going to cool the steppers, so the massive copper block. For some reason, the seal that I was using started to deteriorate quite fast. It could be because the block got a little bit too hot and it started to permanently take on the shape it was being squished to. We could also see the acrylic block. It started to cut in. We had to sand that block with the new seal, and right now it has been smooth sailing. Also, the Carvera Air. Wow, what an amazing product to have in the shop to do all this kind of stuff. Just being able to take this 7075 aluminum and then just mill something out of this is just absolutely a godsend to have in your shop. If you haven't seen the video on the Carvera Air, I will link it right over there. You can watch it. This is an amazing machine and it doesn't cost an arm and a leg. I think it right now comes in at 2.5 grand for that machine, and I would say it is totally worth it. All the mods we have done that are aluminum based, which is going to be my tool plate, then the legs holding in the bolts and our fan duct have been absolutely 100% reliable, and that is just so awesome. I have redesigned the parts that I screwed up, so yeah, if I'm going to sell or give the files away, those should be fixed. So I also want to hear from you guys if you want to see those files be made public, or if you are interested in buying the pre-made kits. I would say I can bundle them up so that you can buy the fan duct, the legs where you clamp the belts, and the tool plate. I can bundle them all up for you guys for what I think is going to be a very attractive pricing. I'm thinking around 150 bucks delivered to your door. So let me know if that is something that you are interested in. Now, this is all for the bare aluminum plating. We can coat it. That is going to be an optional extra. But let me know down below if that is something that you would be interested in. That is also not the only thing that we are going to do with the RatRig right now. We also have an idea on how to tackle the next problem that we have, which is going to be the heat soak problem on the RatRig and for any other aluminum printer right now. To be frank, we have so much metals fighting with each other. We have aluminum with steel rails all over the place, and those are fighting when we are heating up the chamber. And in my case, it is taking anywhere near 40 to 45 minutes until we have absolutely perfect bottom layers. And it is possible with Beacon. It is absolutely possible, but if you heat it up, you really need to give it that time. So we are looking into replacing the aluminum beam right here in the middle, and we are going to use some exotic materials all made by PCBWAY, the sponsor of today's video. So PCBWAY, thank you so much for doing what you're doing. I think we have done some cool stuff today, and I'm really looking forward what we can do in the future with the RatRig and the services of PCBWAY. So I'm super stoked to see that the RatRig is finally behaving, because I was very close to giving up on this project just because of the sheer amount of headache this system has given me. But like always, if we persevere, then there is always a solution for your problems. And if you have problems that you cannot fix at home, then maybe consider PCBWAY in helping you out with anything CNC and 3D print related. Alright, that's gonna be it. This has been an awesome video to make. I hope to see you in the next one, and that is going to be the Behind the Rant podcast. We already canned that video yesterday. Right now I'm getting majorly sick, so it is time for me to make an end on this video. And guys, I see you in the next one.